Hello students, today we are going to study design steps of dog-legged staircase. First step is proportioning of various dimensions of staircase. Available width of staircase equals given in question. Considering two flights of dog-legged staircase, assume width of each flight equals to according to available width of staircase. Space between the two flights equals to width of staircase minus width of one flight into 2. So we will get space between the two flights. Floor to floor height will be given in question. As there will be two flights, each flight will have a height of floor to floor height divided by 2, we will get each flight height. Assuming height of risers as 150 mm to 180 mm for residential building and 120 to 150 mm for public building. Number of risers equals to height of one flight divided by height of risers, we will get number of risers. Number of treads required equals to number of risers minus 1. So we will get number of treads required. Let width of each tread equals to 200 mm to 250 mm for residential building and 200 to 300 mm for public building. Total going equals to width of each tread into number of treads. Total length available it will be given in question. Therefore, width of each landing equals to total length of staircase minus total going divided by 2. Now, this is the plan I had made. Now, you all had to calculate all values or proportioning and mark in this plan. Now, design of staircase. Effective span of flight equals to center to center distance of walls equals to clear span plus 2 into half of width of support. So, we will get effective span of flight, that is D effective, and now we will calculate overall depth D. By using formula thickness of waist slab equals to L effective divided by 20, approx value we will get D effective equals to L effective by 20 and capital D equals to D effective plus effective cover, which is taken 20 to 25 mm for slab. This I had shown in this figure. Capital D is overall depth and D effective is thickness of waist slab. Now, load calculation. In load calculation, first we have to calculate weight of waist slab in plan per meter width of flight equals to capital D under root of 1 plus R square upon T square into 25. Here R and T is risers and treads and D is overall depth which we had calculated in earlier step. Now we will get weight of waist slab in plan in kilonewton per meter. Now second will be weight of steps per meter width of flight. By using formula 25 R into T divided by 2T. Here R and T is again riser and treads. We will get this value in kilonewton per meter. Now total dead load equals to weight of waist slab plus weight of steps. We will get this value in kilonewton per meter. Live load equals to IS 875. Live load taken 5 kN per meter square for stairs, liable for overcrowding, and 3 kN per meter square for stairs, not liable for overcrowding. Now total dead load plus live load equals to capital W equals to kilonewton per meter we will calculate. Now we will calculate factored load WU equals to capital W into 1.5 factor of safety, we will get factored load. For landing, dead load equals to overall depth into density of concrete into per meter calculation in kilonewton per meter we will get this dead load, and live load will be taken in kilonewton per meter. Now total will be dead load plus live load equals to kilonewton per meter. Factored load will be 1.5 into dead load plus live load. We will get this value in kilonewton per meter. This is the beam I had shown in this figure. You all had to calculate this dead load, live load and factored load, and we have to mark this factored load on going and factored load on landing, and we will calculate this length, this distance, and now we will calculate reaction for in under design moment. So we will calculate reaction at supports. Reaction at supports are RA and RB. The both value will be same because of symmetry of diagram. So RA or RB equals to factored load on going into going distance plus factored load on landing into width of loading, width of landing plus half the width of support. So bending moment at mid span we will calculate. It is denoted by capital MU equals to calculate at mid span due to reaction at A or B and factored load on going and factored load on landing. We will get MU bending moment at mid span in kilonewton meter. Now we will calculate maximum bending moment allowed for a singly reinforced section with Fe415 bars. So formula used is MU limiting equals to 0.138 FCK BD square. We will calculate MU limiting in kilonewton meter. Now we will compare MU and MU limiting value. If MU is less than MU limiting, then section can be designed as singly reinforced section. Now we will calculate area of reinforcement. Area of reinforcement formula used is MU equals to 0.87 Fy capital AST into D in bracket 1 minus AST by BD into Fy upon Fck. Now putting all values in above equation, we get quadratic equation. Solve on calculator, we will get AST in mm square. Using diameter of bar, calculate spacing, and the spacing formula is small AST divided by capital AST into 1000, where small AST equals to cross sectional area of one diameter bar, and its formula is pi by 4 into diameter square. We will get this value in mm square. Now provide diameter of bar at the rate dash mm spacing center to center. Now distribution steel equals to 0.12% of area for Fe415 and 500 steel. And now putting these values in this formula, we will get 0.12 upon 100 into B into capital D. Here capital D is overall depth of slab equals to this value will come in mm square. Now distribution steel equals to 0.15% of area for Fe250 steel if used, and its value will be 0.15 upon 100 into B into capital D. Here capital D is also overall depth. It will calculated in mm square. Now we will calculate spacing, and its formula is small AST upon capital AST into 1000, where small AST equals to pi by 4 into diameter square. Use diameter of reinforcement for distribution bar equals to 8 mm or 10 mm. Therefore, provide diameter of bar at calculated spacing in mm center to center. Now next step is development length, and its formula used is LD equals to 0.87 Fy divided by 4 tau BD, and its value will be calculated in mm. And now providing length of bar at points where LD is required. Now next step is reinforcement detailing. We had calculated AST for main bar and for distribution bar. Now in this reinforcement detailing, we will mark all calculated values, that is overall depth, LD, provide this bars at the rate this mm center to center in main, bars and for development length, and we will put all length of going and landing, and we will mark width of support in this diagram. So this is called reinforcement detailing. Thank you, students.